Okay, hi there, this is video number 2 for your revision. Okay, all on materials. There's 2 videos for materials for your test this week. Okay, this one's going to cover properties, woods, metals, polymers. The other one will do fabrics and papers. So, let's quickly look at what we've got to get covered. Okay, we've got material properties. Every material comes under these properties. Properties can be broken down into 2 different groups, mechanical and physical. Mechanical covers anything that has a force applied to it. So for example, tensile strength, compression strength, and also things like hardness, toughness, ductility, elasticity, plasticity, and how brittle it is. This is where we're testing it to breakage. Whereas physical properties can be observed or measured without actually changing the material. For examples, odour, colour, magnetism, conductivity, what does it do when we shine light at it, what's its density, okay, how does it respond to chemicals and those sort of things. Okay, often you will get questioned on these. So you've got torsional strength, tensile strength, compression strength, bending strength, and shear strength. Remember that strength itself is not a property. You cannot say this material is strong. You have to explain how it's strong, okay? And remember, strength is a capacity, okay? Even paper is strong up until a point, okay? So our first material, timbers, okay? You've got the sheets that you need to be able to give examples of all the timbers. This is what you need to be able to talk about. You need to be able to talk about the 2 main groups. So you've got softwood and you've got softwoods and hardwoods, okay? Another way of looking at that is the types of trees. So coniferous, okay, are these sort of triangular pointy trees. They don't have leaves, they have needles, they have fir cones, they grow all year round. Because they can grow all year round, they grow really, really rapidly, so they're not very dense and therefore they're quite soft. Because they grow all year round, they grow quickly, we grow a lot of it, okay, it's a lot cheaper. Whereas then hardwoods, okay, they are the round top trees, so oaks, okay, and beeches. They only grow in the late spring, summer and early autumn. They drop the leaves in the autumn, they don't grow in the winter, therefore they are slow growing, so they're a lot more dense, okay. Because they are slow growing, it takes a lot longer to grow them ready for cutting, so they're a lot more expensive, okay. All right, you're going to need to know about the processing. So you've got felling, conversion, which is the way we slice up, and seasoning. You can season while it's still in trunk form, or you can cut up and slice it and then let the air get through it in a nice neat stack to let it dry out properly. If you don't dry it out, okay, it starts to shrink and warp, okay, and you get all of these sorts of problems. So you get shakes, bows in it, twists, okay, the knots can sort of contract and drop out, okay, and you get all of those sorts of problems there. All right, it's really important that we season our wood. Okay, and then you get your stock sizes, okay, so you get strips, you can be cut into squares, boards and planks, okay, you also get the round formation, so it'd be large timber columns, okay, or even very small little mouldings that you get the nice detail stuff you get on wood frames and stuff like that. Okay, we've also got our man-made boards, MDF, plywood, chipboard, OSB, veneers, okay, easy way of remembering it is slim chimp, so it's squashed, it's layers, industrial, they're man-made. Okay, and then examples are chipboard, hardboard, inexpensive, MDF and plywood, okay? They are all precision engineered, so you can, if you're trying to make something absolutely perfect, you know you're going to get exactly the right size, whereas natural timber, okay, is unstable, as we've seen, it twists and warps, changes size, okay, it's not a precise science, okay? All right, you do need to explain what plywood is and why it's stronger, okay? Again, all that information is on the sheets we handed out, but there are YouTube videos for you to look at and find that will help you describe the process. Okay, metals, nice and easy. 2 groups again, non-ferrous and ferrous. Okay, we'll look at ferrous first of all. Ferrous will always be iron-based. Remember, the chemical code is Fe. It's always going to be magnetic if it's got iron inside it. Okay, it rusts in the presence of water and oxygen. Okay, it comes from iron ore. It's often mixed with carbon. Top tip, the more carbon means less malleable, okay, but it is harder. Good examples are cast iron, stainless steel, and mild steel. Every other metal is non-ferrous, okay? They're non-magnetic. It may oxidize. A good example is the Sheffield University building, okay, which was a nice golden brown colour. Okay, it was copper, and then it went into green because that's the way it oxidized. That's what the architect wanted it, okay? But it may also be non-reactive, so for example, gold. Okay, it comes from natural ores, meteorites, or it can be synthesized, okay, which means it can be man-made. Good examples, copper, titanium, aluminium, or gold. Okay, you do also get, okay, so these are the stock forms, so flat bars, rounds, this is the form it comes in. Structural stuff comes in this sort of stuff, so it's actually looking at the way the structure shape can make it stronger. So you've already got the compression end and the tension end. Okay, the further apart they are, the stronger it's going to be. Okay, final thing you need to know is alloys. Okay, should be a combination of 2 or more elements or raw materials. Okay, that are combined. Okay, to make them more suitable, desirable. So we take the properties of one, add it to the properties of another one. Okay, for example, brass is an alloy. Okay, of copper and zinc. Copper is malleable, while zinc adds a hardness and corrosion resistance. So it's brilliant for this sort of little miniaturette statue stuff or big sculptures. And finally for this one, plastics. Again, you need to know a little bit of science for this one. So plastics are made of polymers. Okay, a polymer is lots of monomers. Okay, which are these sort of chemical chains here. Okay, it's always derived from oil. Okay, which is hydrocarbon. Okay, and you can see the hydrocarbon chemical chain just there. All you need to remember is that poly means many, polymers are lots of monomers, mono means one, okay, and lots of those make up plastic, all right? What we need to know is how they react to heat, okay, and we've talked about the spaghetti noodle stuff. In a packet, they're cold, they're dry, they're all intertwined, so all those polymers are intertwined. The minute you get them wet and warm, they open up, straighten out, and then you can then bend them, okay? All right, and the 2 groups that you need to know, again, they're on your sheets, you can find your examples there, are thermoset and thermoplastics. Thermoset are easy. Once they've been heated, they're set. You cannot change them, okay? And that's because the molecules are cross-linked in 3 dimensions and makes them very, very strong. Unfortunately, because you can't reheat them, they are not recyclable. Thermoplastics, okay, can be reheated and remolded. The bond between the molecules is strong, but is changeable. Okay, these types of plastics can be recycled. There are examples there, but they are on your sheet. Okay, worth remembering that there are natural and synthetic polymers. Okay, natural polymers come from things like rubber, from the environment, they occur naturally. All right, whereas these ones are man-made, they come from oil and they're heavily processed. Good luck with your revision. Find video 2.